Greetings everyone! In this video, we are going to talk about dining philosophers' problem using semaphores. So if you're interested, then let's start. What is dining philosopher's problem? The dining philosopher's problem is a typical example of limitations in process synchronization in systems with multiple processes and limited resource. So, it is a classical synchronization problem in the operating system.
How does the dining philosopher's problem work? In dining philosopher's problem, 5 philosophers are seated around a circular table and their job is to think and eat alternately. There are 5 bowls of noodles and 5 chopsticks for each of the philosophers. The following are certain conditions a philosopher must follow. First, if a philosopher is hungry and wants to eat, he must use 2 chopsticks adjacent to him. Second, a philosopher can only eat if both of his left and right chopsticks are available. And third, if the philosopher's immediate left and right chopsticks are not available, the philosopher places their chopstick on the table and resumes thinking.
How to solve the dining philosopher's problem? The solution to dining philosopher's problem is to use a semaphore to represent a chopstick. In semaphore, it employs 2 atomic operations, which is the wait and the signal. So, a chopstick can be picked up by performing a wait operation on the semaphore and released by performing a signal operation on the semaphore.
To demonstrate the dining philosopher's problem, let's implement it in C language using the Ubuntu terminal. Here, I already have a C program that I copied from this website. In this program, we start by importing the libraries pthread for threads and semaphore for synchronization. The pthread library is used for multi-threaded programming, which allows us to run parallel subroutines using threads, while the semaphore library is used to perform semaphore operations. Here, there are 2 semaphores that are being declared, a mutex semaphore and an array semaphore for the philosophers. The mutex is used so that no 2 philosophers may access the pick up or put down at the same time, while the array is used to control the behavior of each philosopher. If we try to run this program, we can see here that the philosopher has 3 states: the thinking, hungry, and eating states. The output tells us that if a philosopher is hungry, he will take 2 forks and start eating. If he is done eating, he will put down the 2 forks he used and start thinking again. With that, it will allow another philosopher to take 2 forks and start eating, and the cycle will go on forever.